Okay, we were talking about we are discussing about vectors and writing a vector in the component form. So any vector can be expressed as the sum of its components along the different axes of a coordinate system. We'll focus on the Cartesian coordinate system having the three axes. Let us say the x-axis, the y-axis, and the z-axis. So as we had discussed, the unit vectors along this x-axis is I, along y-axis is j, and along z-axis we call it k. If I have any vector a with respect to the origin, we can call it the vector OA. We represent it with a bar and an arrow on top. And in component form, this vector OA, or also we can call it the vector A. Okay, suppose we call it the vector A. The vector A can be represented as A is equal to IX plus JY plus KZ. Can also be represented as this, where the x component of the vector AX is equal to X, AY is equal to Y, and AZ is equal to Z. This is the magnitude of the vectors along the x-axis, along the y-axis, and along the z-axis. So this notation that we are using of the vector A, the notation that we are using for writing the vector in the component form, this is very important when we go into mathematical physics, when we discuss about vector algebra. Okay, so either it can be written as, you can also write it as, no harm in writing as this, IAX plus JAY plus of KAZ. It can be written as this also, okay, where AX is equal to X, AY is equal to Y, and AZ is equal to Z. Now let's go ahead. We need this because we'll be discussing about vector algebra. Vector algebra means how the vectors, they add up, they subtract, and what laws of algebra do they follow. Okay, so they obey certain laws. Vectors also obey certain laws. The first one is vector addition. We were discussing about it. A vector along this direction u and a vector along v, so resultant will be along this. Okay, one force is pulling along this direction, the other force is pulling along this direction, so the particle will be moving in this direction. The resultant force will be along this direction. So this is vector addition. Vector subtraction. Vectors also can be subtracted from one another. Vector subtraction basically means the addition of one vector and the negative of the other vector. Say, I can show you something like this. So I have a vector A and I have a vector B. Okay, I have a vector A and a vector B. So A minus B is basically equal to vector A plus negative of vector B, minus of vector B. Okay, so this is vector subtraction. So this means negative of a vector means if I have a vector A in this direction, minus of vector A means same vector in this direction, equal and opposite. Okay, so this is the negative of the vector. So any vector A minus of B, as I said, is equal to A plus the negative of the vector B. Okay, right. So let's go ahead. So here you can see the vector A minus vector V means you can imagine this vector to be shifted here, okay? So the negative resultant will be along this direction. So these are some things which you have already learned, just a revision of what you have done. So we using the same two vectors, we can understand it bit better. Vector A along this direction, x-axis, vector B along this direction. So A plus of B is along this direction. So minus of the vector B means it will be equal and opposite in the other direction. So A minus of B is this one. Vectors, they obey the law of addition and subtraction. They undergo addition and they can undergo subtraction. That apart, when we add two vectors, the components also get added up, right? This is something, again, in component form, we need to understand. So let's see this here. So if I have a vector A in two dimension is equal to, say, IAX plus JAY, and I have a vector B which is equal to IBX plus JBY. Then if I add the vectors A plus of B, that simply means IAX plus JAY plus of IBX plus JBY. Okay, so what will happen? The components will add up. So the total vector A plus of B will be equal to IAX plus BX plus JAY plus BY. Okay, so this is addition in the component form. Same thing will happen for a vector in 3 dimensions. So it will be not only IAX plus BX, you'll have IAX plus BX plus JAY plus BY plus K term also will come, AZ plus BZ. In 3 dimensions also, in component form, we can add. Now, vectors also undergo multiplication. A vector can be multiplied with a scalar. So here we are showing a vector V. It is multiplied with a scalar 2. So it's nothing but twice of the earlier vector. You can multiply with minus 2, it will be opposite. If you multiply with 0, it becomes a null vector. It has neither magnitude nor direction. You may think why this is necessary, but later you will see the null vectors also are important in mathematical physics. Okay. So the next thing is vector multiplication. Two vectors can be multiplied. There are two ways in which vectors can be multiplied. Rather, there are two products. One is what is called the scalar product, and another one which is called the vector or the cross product.